Ma'am, start recording.
Okay, great. Okay, so good morning all. Welcome to the 10th lecture of the course. We have been looking at loops in the last class. We have started looking at loops, and these will give us the power of doing several things. And today we'll again list out a few tasks that we want to do. We had listed out certain tasks in the last class. We'll finish them and move on to some more interesting tasks in today's class. And then as a follow-up of this, you will perform similar tasks or write programs for performing similar tasks in the lab. Okay, so the last two classes we have looked at these two constructs, the switch, which is a multiple selection statement, and the while loop. We have looked at its syntax, its semantics, and fine details of each of them where things can go wrong possibly, or mistakes that one can make. The tasks that we have done are printing simple messages using the switch statement, a one-time mini calculator, and then we modified it to a mini calculator which did a couple of operations, and we again saw small corner cases for each of these tasks. So what we will do today is what we started in the last class, that is finding the min of n integers. We started writing a program, and we did not quite finish it. There were two versions of this problem. That is, we are given input n, and we are going to find the minimum of n integers. These n integers can be anything. The second version was that we are given, we want to find the minimum of positive integers. We are not told in advance how many integers will be given, but the stream of integers will be terminated by a negative value, and there is where you stop. So these are the two versions. We'll look at them. Then we'll look at this task of determining whether a given input integer, we'll assume that it is a positive integer, is a prime number. And then finally, we'll look at computing the GCD of two integers, that is the greatest common divisor, which will be an interesting exercise. Again, the last task will have two positive integers. Okay, any questions, comments on the things that we have done earlier, or anything that you want to bring up? Great. So this was the way. So we are looking at finding the min of n integers. This is a simple task, but the version that we are looking at is there are n integers that user is going to provide. So the user is going to provide a value n initially, and then we are going to take that input from the user, then initialize some counter to count n, and then as long as we have not finished taking in the integer, scan the input, that is take the input from the integer input from the user, and modify min if needed. This is the template of our program. This is something that you should get used to writing on a piece of paper or in your text editor before you start typing code. Okay, so instead of going back to the REPL.it, because it takes a little time, I'm going to show the program here. If required, we'll go to REPL.it. So we had written, I have taken the variable names almost the same, but changed the program a little bit. So we have in n current integer a and min. A is our counter, and in the part that we were writing in the last class, we had a initialized to 0. I have initialized a is equal to 1. I had also asked you to complete the program with a initialized to 0. I hope most of you could do that. And then what I have done is, earlier what we were doing is we were scanning one of the inputs outside, because we didn't know what to do regarding where to initialize the min. We don't know the range. We can also do some other things, but what I have done here is I'm going to take all the inputs in the while loop. So while a is less than or equal to n, because I have initialized my a equal to 1, I will have this condition, a is less than or equal to n. I'm going to, of course, modify a in the loop, which is by this a plus plus. Every time I go into the loop, I want to scan the input and do something, which is modify the min if the current integer happens to be less than the current min that is there. But min has not been initialized for the first time. And that is what we wanted to do by taking one input outside. what I'm going to do is just say that if A is equal to 1, that is, this is the first input that I'm taking, then I'm going to initialize min to be equal to the current int. This is happening only once, and that is why I'm doing this here. And then, of course, this statement is redundant when A is equal to 1. I can also write an else, but doesn't matter. If this check is done, it does not hurt us. And then we simply say that for all other integers, if current int is less than min, then we set min is equal to current int. And that's all. The important point is that A has to be incremented, otherwise this loop will be an infinite loop. Once you are done with this loop, the minimum the min variable is going to contain the minimum of the n integers that are given to you. So any questions or comments about this program? Okay, so I'll quickly make some of the important remarks. So once you write some program using a while loop, and if there is a counter or if there is an expression, this in general it is the test expression updated in the while loop. That is something that you need to check. The second is about the corner cases. What happens to this program when there is a single input? How does the program behave? Let's say there is a single input. Does it behave correctly? If there is no input, that is, if the user inputs 0, what is the output of the program? Any thoughts? What is the output of the program? If n is equal to 0, it does not go into the loop, and therefore it will simply print whatever is in the minimum variable, and that could be some garbage value. So you can expect any garbage value to be written out if you have no input. So if you want to take care of that case, you should write an if condition outside this. That is, if n is greater than 0, only then print the min. And then, of course, you want to test the corner cases. That is, min occurs as first element or last element, and anywhere in the middle, you would want to do these test cases. These are some things that we would want to think about before writing the program, when we are designing the program. Okay, now once we have designed the program, I want you to observe the following about the program. So when the control is at this scanf statement, we have set up our program in such a way that whenever we are at this scanf statement, we are scanning the ath input that is given by the user. So the first time it is the first input, the second time it is the second input, because the value of A has changed accordingly. So this is the ath input that we are scanning. And similarly, just before this A++ statement happens, that is when we are here at the end of this if statement, what we have is that the variable min contains the minimum of the first A elements given by the user. So if you have 10 elements that the user is going to provide, and if the user has already provided 6 elements, then at this stage min contains the minimum up to the first 6 elements. So this is what is called as a loop invariant, and the loop invariant is something which is a very useful tool for us to argue about the correctness of our programs. Although that won't be in the scope of this course completely, at some points we will be talking about the loop invariants where it is relevant. Any questions, comments here? I'll quickly take a look at the chat if there are any messages. Okay.
What did you say about loop invariant or something? There was an audio issue.
Okay, what I am saying is that these two statements that I have written below the line on the right hand side of this slide are what are telling us how this loop behaves, right? So the loop, I mean, the variables do change. The value of the variable A is going to change. The value of the variable current integer and min are going to change as the loop executes. So if you are executing it for the first time, the values are different. For the second time, for the 10th time, the values are different. However, there are some invariant properties about this loop. That is why it is called a loop invariant. And these are important because when we execute programs that have loops, the variables are changing, but our program has some behavior which is most likely guided by what we think of as when we are designing this. And this is what is the design that we have in mind. When the control reaches this statement, we are scanning the ath input. When the control reaches this statement, that is the end of if, we have actually found the min of the first a integers that are provided by the user. This is some invariant that we are saying, which is true for every execution of this loop. Is that clear?
Okay, ma'am. Okay.
Yes. Okay. So there are two questions. One is, can we store it using an array and do all of this? You can store it in an array, but at the moment we have not introduced arrays. The second thing is arrays are not required. Not that we don't have the ability to define arrays, but it is not required. User is giving you inputs. You simply want to find the min. So you just require that one value, not all the values. And the second question is current int is, I think it is related to this, is less than or equal to. So less than or equal to is also okay, but there is no need to do the change, right? So it is, if current int is strictly less than min, then only you want min to change. So that is what is done by this. Okay. So are there any other questions? Okay, so we'll go to the second thing that we wanted to do. That is, we want to compute the min of positive integers. So now we are given this guarantee that we are going to get only positive integers. As soon as we get a negative integer, we are going to terminate the program. That is, we are going to say that we are done with the input integers. We now just need to exit from the loop as well as the program. So it's fairly easy to modify the given program that we had earlier. I'm going to show you a program. Please read the program very carefully, understand it, and in the chat message, please write down what is the output of the is the behavior correct? Is there an issue? Is there a syntax error? Is there a logical error? And so on. So please read the program carefully. It just has gotten rid of the variable a because there is no counter needed now. It takes in the current integer, initializes min with the current integer, and while the current integer is greater than or equal to 0, it does what it is required to do. So please read this program and stare at it for a few seconds and then tell me what is the behavior of this program. So please write down the messages in the chat so that everybody gets time to think about it. So I see so much silence in the chat messages that I think, am I connected? Okay, so now I'm seeing people writing. Okay, one of the things is what is this n doing? N is not required. You can delete that n also. I agree with that. Sorry about that. N is not required. Yeah, so n is some redundant variable. Don't worry about that. Okay, so I repeat what is the goal of the current this thing, goal of the task that we are given. We just 1 second, Rakesh. So the goal of the task is we are given some positive integers. The first time we see a negative integer, we assume that the program has terminated and we want the min of the positive integers. That is why the heading of the slide says min of positive integers, right? Okay. Okay, so there are a couple of answers, of course, which many of which are correct. I mean, they are pointing out the issue. There are also some of the questions that I will go into. So yeah, before that, Rakesh, do you have a question? Okay, I request everybody else to mute if they are not speaking.
Ma'am?
Okay. Yes.
I have
Yes,
a doubt, ma'am.
Rakesh.
This is
Yes.
Kanikesh, ma'am.
Okay, Kanvikeshwar. Okay.
Yeah, I have a doubt, ma'am. Um, here actually we need to input values, ma'am, for scanf for the current end. So will we be inputting values like 2, 4, 6 and go, and will we be going on like that? Because there is no printf statement. I don't know like where to stop.
Okay, so assume that, okay, so we'll also write a printf statement, doesn't matter, but you can, okay, so the way this program we can execute is, I could have done it there, but okay, so you will be prompted something. It would have been ideal to say input the next integer, but you will, let's say you are prompted input an integer, then you enter it and then you type it out and press an enter. And even if you are not prompted, the program is just waiting. And therefore you input that integer, press enter, input that integer, press enter. Whenever you want to stop, you enter a negative integer.
So until we print, until we enter a negative number, we won't get the minimum value, right?
No, we won't get any printf statement because we haven't written the
Okay.
printf statement. Yeah.
Okay.
Okay. So there are a lot of chat this thing. So okay. So the first question that I want to ask is there are some comments which are saying that if you give the second input integer as negative, then this is not going to terminate the program. Does the program terminate if you give a negative integer? I mean, suppose you have a stream of integers and let's say some positive integers followed by a negative integer. Does the program terminate? Yes, the program does terminate because it says while current int is greater than or equal to 0. So there is no problem with termination of the program. So the program does terminate. If in fact, if you give the first input as whatever is a negative value, you will terminate the program immediately. You will not go into the while loop. So that is not the issue. The issue is that the program does terminate. It takes the current integers as desired. However, the current integer, the last integer, that is the termination integer, is also taken as a current int, and the program doesn't understand that it is something which it should ignore because we haven't told the program to do so. So therefore, let's say you have input like 5, 10, 7, 3 and then -1. So till the last positive integer 3 is the current min. But when you take -1, that -1 is also a valid integer which goes here. And then it says if current integer is less than min, which always is going to be true because you have input positive integers till now. Therefore, the min is always going to be the last integer, which if it is -1, it is going to be -1 or the negative integer with which you are terminating the program. So the desired behavior is not there because whatever is the last integer, that by definition is the current, I mean definition is a negative number, and that will be the minimum of all the integers that have been input. Therefore, that is the output. So you don't get the desired behavior. A very small and possibly fictitious kind of a task, but it is still something which helps us illustrate this. So what we need to do is the following, that is, if current int, so I have just done a small modification, everything else remains the same. If current int is less than 0, then you break. So where does this break take you? It skips all the part that is below in the loop and it takes you out of the loop, where it will print out this. So this is something that is that will save you from the previous mistake, that is, the output of the program was always a negative integer. So this is something that again many of you have suggested. So this or some such thing that you have suggested. So which is good. Any questions or comments here? So there is still some kind of a nagging behavior. If you have the first value as negative, it will still print out the value as min is equal to that negative value, but you don't want to do that, in which case you can add a check in the end and again save yourself, just like what we did for the earlier program. So this is something that these are the corner cases that we need to take care of. Okay. Okay, so one of the questions is, why are we writing the scanf statement twice in the program? Because our condition says current int is greater than 0. What you want to do is possibly initialize current int to be greater than 0 and do it. Is that what you are interested? I think Sahana, right?
Ma'am, because
asked
we
this
have
question.
taken input once, no ma'am. So I thought, why should we write again, like scanf statement again? I did not get it.
Okay, so I'm not saying that this is the only way. You can get rid of this scanf statement by doing a proper initialization of the current int. Right? The current int is, you should go inside the loop. Is that clear?
Yes, ma'am.
Yeah. So the comment, if it is that can we get rid of this scanf statement? Yes, we can get rid of this scanf statement. Okay, any other question? There are a lot of chat messages, so I am unable to read all of them in this time. But
Ma'am,
yes.
ma'am, instead of writing if statement with break, can we write the if condition current int less than min condition before the scanner in the while loop, so that the value of the min can't be updated by the current
Okay,
int,
good.
and it will
Good.
check the
Okay.
condition.
Yeah. So one of the suggestions is that when is this okay. So that in that case, this cannot be combined with the current suggestion of Sahana, where you are taking all the integers inside the loop. So what it is saying is that okay. So one of the suggestions that I think Sonish or one of you has given is, can we move this if current int is less than min to before the scanf statement? So in which case we can we come here, we write it, and then take the next input. If the next input happens to be negative, we never go inside the loop, which is also a correct way of modifying this. However, you have to be careful where, are you bringing all the scanf inside? So both of them should not be combined. Okay. So I assume that there are no other questions or comments. Then we move to the next task that we have. We have the task of deciding whether a number is prime. It's a simple task. Maybe you have written a program for this earlier. I just want to illustrate a few things. So as we know, a number is prime if it has no divisors other than 1 and itself. So again, we need to get into this practice of writing down what we have to do before starting to code. So our template of our program is going to be this, that is, start checking from 2 to n minus 1. If any of these integers divides n, then we declare that it is not a prime. If we fail, that is, if none of these integers divide n, then we declare that it is a prime, right? So this is the template of the program that we are going to write. And again, if you, since many of you have seen all the basic constructs, you will naturally think of writing this as a for loop, which is also fine. But at the moment, we are only going to exploit the while loop. Okay, so there are certain suggestions here that up to n by 2 is sufficient, up to square root n is sufficient. I agree with all of them. At the moment, we are just going to do this very simple check. Yes, these are correct that we can only go up to n by 2 or in fact up to square root n. Okay, so this is the template of the program. Again, something which is not difficult to understand. We are taking the input from the user. The important part is we are going to run a counter or a increment value with a value which is going to run from 2 to n minus 1. That is why our I is less than n. And we are going to run it all the way, and that has to be incremented in the loop. So this is I is equal to I plus 1, which could have been I plus plus. And this flag is something that we are setting if we find a divisor. So again, the loop invariant for this loop is that when you go inside the loop, you will go inside the loop. If the flag is 0, then we still haven't found an integer, found a divisor. If as soon as the flag becomes 1, in fact, we will not even go into the loop once again, because as soon as the flag becomes 1, we are always going to break out of the loop and come here. So if flag happens to be equal to 1 when we have broken out of the loop, then we have found some divisor, and that is what tells us that this integer is not a prime. So again, it illustrates the use of break. Is it necessary to use this break? No, but it is convenient to use this break. That is, as soon as you have found a divisor, you just break out of it. You don't have to go to all the way up to n minus 1, the way we had written this. So as I have already agreed that we want we can go up to square root n, we can go up to n over 2. That is something that is correct, but at the moment this is the way we have thought about the program. Yes, so as I said, okay, so the question is that can we get rid of this flag by doing some test here without the flag? Yes, we can do the test without the flag. If I turns to be n and we don't have this flag at all, then we know that we haven't found a divisor, in which case you will declare that it is not a prime. Any other question?
Ma'am?
Yes.
Ma'am, what to do if n is 2, ma'am? This won't work now, ma'am, if n is 2.
Okay. Okay. So what will happen if n is 2?
It will print that it is not a prime number, ma'am.
Okay. Why does it happen?
Because we've started I with 2, so the remainder will be 0.
But it won't go into the while loop, right? Because if n is 2 and I is 2, 2 is not less than 2. So flag will still be 0 and it will say it's a prime, right?
Oh, okay.
Let's run the program when I is equal to, sorry, the input n is equal to 2. So n is 2, I is 2, flag is 0, I less than n. Is it going inside the loop?
No,
Ma'am,
ma'am.
Okay, so it doesn't go inside the loop, so flag remains to be equal to 0. And in which case, what does it print?
Only.
It will print out that it is a prime, right? Yeah, so
ma'am,
yeah,
ma'am?
let me just finish this. So somebody had asked this question. Is that clear that I is equal n is equal to 2 is taken care of?
Understood.
So sorry, I don't know who had asked this question, but okay. Yeah. So some other questions that are there. So is the flag necessary? I have already said that the flag is not necessary. Yes. Okay, n is equal to 1. Okay. n is equal to 1, what do you want? Prime or composite or not prime? Okay, so we will say input integers are greater than or equal to 2, right? That is the input to this. Of course, you can again say that if n is equal to 1, you want to test it ahead of time. Good. You have to find out that it is, you have to find out these corner cases, but these are some things that you take care of it earlier. So n is equal to 1, neither prime nor composite. Okay.
Ma'am,
Yes.
ma'am, like they were saying about I equal n equal to 2 case, no, ma'am. It won't work. It won't enter the loop.
Yes.
For that, can we initialize I equal to 1, and as soon as we enter the while loop, can we just write I plus plus so that it becomes 2?
No, but what do you want? Currently, it is not entering the loop and it is correctly printing it out, right?
Yes, ma'am. For n equal to, it won't enter the loop.
Okay, you
But we
want it
need
to
it
enter
to
the
enter the
loop
loop.
for n is equal to 1.
We need to
No,
we
what
need to
is,
enter the loop, ma'am, for n equal to 2.
I mean, okay, so it depends on what you want to do. I mean, you want it to enter the loop, then you should change the program. But at the moment, it doesn't print out a incorrect behavior. That's what I'm saying.
I didn't get it.
Okay, so for n is equal to 2, okay, whether it enters the loop or not is a different question. Is the output correct is the first question. Is the output correct?
Output for which value, ma'am? Which value of n?
We are discussing n is equal to 2.
Okay, for if it's for n equal to 2, then the output will be wrong, ma'am. Because say if we
Okay, so I went over it, but I'll go over it quickly again. N is equal to 2, I is equal to 2,
okay,
flag is
solved
equal
it
to
fine,
0.
ma'am.
Yeah.
Yeah, I get it, ma'am. I get it. Output will be correct, ma'am.
Okay. Okay. So yeah, so these are good questions. You have to nail down these questions when you write a program. Each of these questions, even n is equal to 1 is a valid question. Please put in a check at the beginning of the program. One of the other small things is that this
Ma'am,
one
I had
is
a doubt, ma'am.
just 1 second, I'll just complete this. If 1 is equal to flag is something that is a correct valid statement, and this is something that I would like you to put yourself into the practice of writing rather than flag is equal to 1. We have discussed this earlier also, that if flag is equal to 1 is what you want to test, whereas you write flag is equal to 1, this can be a very incorrect behavior of the program because it is setting flag equal to 1 and the return value of that assignment operator will be something which is 1, which is non-zero. Yes, Ishtartha.
My doubt got clarified, ma'am, in your explanation.
Okay, sure. Great. Okay, so please note down in your minds as well as in your notes if you are taking about the things that we discuss for this program, which are all very useful. Okay, so this is what we have written here. Let's now go to the third task, which is very interesting, which is computing the GCD of two positive integers. So we'll stick to two positive integers. We are not given 0 and we are not given negative integers. We are given two positive integers. We want to compute the GCD of x and y. So I'll start with a very, very simple idea, which is our high school method that we learn. So we know that the GCD is the largest common divisor. Of course, we have this compute the factors and so on. We are not going to go into that method, but we are going to say that, yeah, let's find the minimum of these two integers, x and y. Let's call it z. One of x and y is z, and if they are the same, then they are equal. And then we simply go from 1 to z and check if I, whatever is this value of I, divides both x and y. If it divides both x and y, you update it to be the GCD. and you continue doing this as long as you don't reach Z. The first time you find this, you should not return because that is not the GCD. That is some divisor, but it is not the GCD. So this is what you want to do. In fact, people who, just who have written this or thought about it will say that, why do you go from 1 to Z? Why not do you go from Z down to 1? Yes, you can go from Z down to 1, in which case you must break as soon as you find the first one that divides both X and Y. Right, so we are going to first write a small program using this idea and then refine on this idea. Any questions or comments here? Okay, so this is again a snippet of the program. So it says I will first compute Z, which is the min of X and Y. We all know how to compute the min of integers now. By now we are very comfortable with that. This is only two integers X and Y. So if X is less than Y, Z is X, else Z is Y. Now we initialize GCD to be equal to 1, and this counter that is going from 1 to Z to be equal to 1, and then we keep incrementing the counter till it reaches our minimum value, which is Z. So this is the test condition for the while loop. As long as I is less than or equal to Z, you go inside the while loop and check if this I divides both X and Y. If it divides both X, it divides X as well as it divides Y, then it is a common divisor, and therefore you update your current estimate of GCD to become I. So this is the natural translation of your idea here to the program, C program that we have written. And of course you need to modify I because I needs to get incremented, and this is how your program will run. Of course you can say I is initialized to Z while I is greater than or equal to 1, do I minus minus, and that can also be done. But very importantly, you must break, otherwise you'd always run down to 1 and your GCD will always remain to 1. Okay, so okay, so the first question that is there is about min. If X is equal to Y, so first of all, I think you mean X is equal to Y, which is okay. If X is equal to Y, then Z won't be initialized. Is that true? So the claim is that Z doesn't get initialized if X is equal to Y. That is not true, right? If X is less than Y, then Z is equal to X. In the other case, so what are the other cases? The other cases are X is equal to Y or X is greater than Y, in which case Z will get initialized to Y, which is fine. Again, X is less than or equal to Y should have also been fine here, but this current minimum finding is not incorrect. Okay, any other comments or questions here? Any incorrect behavior of this program, for any values or anything that is incorrect? Okay, so actually this is a correct program. There is no issue with this program. But I'm going to take this example of GCD and illustrate something which is very beautiful and one of the oldest algorithms, which some of you may know, but for the interest of completeness and everybody's this thing, it will be nice to illustrate this. So this idea is a very powerful and very nice idea by Euclid. It's a very old idea. So what it says is that this is a completely different way of thinking about GCD. If let's assume for the moment that X is the greater of the two between X and Y, that we can arrange by, we know how to swap two integers. Let's say if X is the greater of the two, then if Y divides X, we are done, because we know that then Y is the GCD of these two integers. Else, can we come up with a smaller problem that we can solve? So what Euclid observed is that GCD of XY GCD of two integers x and y is the same as GCD of x minus y, y. Right? So this is a mathematical statement. If you make this such a statement, you need a proof. And it's not difficult to come up with this proof. If you say that GCD of x and y is k, then you know that k divides x, k divides y. Therefore, you know that k must also divide this x minus y. Where is this coming from? Just think about it for a minute. And since k divides x minus y and k divides y, that is coming from this statement itself. You know that the GCD of, so of course k is a divisor of these two numbers also, x minus y and y. Therefore, the GCD of these two numbers, x minus y and y, will be greater than or equal to k. Similarly, if you assume that some other value, let's say k prime is the GCD of x minus y, y, you should be able to show that the GCD of xy is greater than or equal to k prime. So what if you want to show that two sides of the inequality are the same, two sides of an expression are the same, you can show that one of them is greater than or equal to the other and vice versa, and then you should have that both of them are equal. So this proof is something that I will leave it to you to, I mean, just write it down. This is something that you may have thought about, you may have read it somewhere, but this is something which is a small neat thing to do. So how does this allow us to come up with a better way of writing the GCD program? So let's see this on an example first. Let's say we have GCD of 1034 and 230. Yes. Yeah, is there a question? Okay, so let's say we are interested in computing the GCD of 1034 and 237. Again, some chosen arbitrary numbers. Then what this earlier statement says is you can simply compute 1034 minus 237, which happens to be 797, and then the GCD of the second number, which is 237. And why stop here? 797 and 237 are not very familiar integers. Let's go ahead. We further subtract 237 from 797 and we get 560 and 237. We do this again, which is we get another set of integers. At some point, you may get something which is smaller, right? Smaller than 237. At this stage, what do? We know that GCD of AB is exactly equal to GCD of BA. So just flip it and say that it is GCD of 237 86, and then you do this subtraction repeatedly. So as long as you have x is greater than y, you keep doing this subtraction and you keep getting a pair of numbers. If you happen to get x is less than y, you swap the numbers and keep repeating the subtraction. So this is what I have done. And this is not the place where we will stop, but 221 is something that we will realize that they are co-prime. And therefore, we will know that the GCD of them is 1. You may realize it much earlier than me. You may realize it at 2185, or you may actually realize it at 1034 and 237. But at the place where you see familiar numbers and you know the GCD of them readily, you just stop and output the GCD. So this is something which is a very powerful idea, and we'll see what it means by it being powerful. But is the idea clear? Any questions or comments? Okay, so what we have done is we have kept on repeatedly subtracting 237 from this three or four times from here. Can we do it in one shot? And if we want to do it in one shot, we do have a nice operator to do it. So what actually I should have written this as idea 3, which is again Euclid's idea written in a different way. That is, if you have two integers x and y, and x is greater than equal to y, if we know that x mod y gives us 0, that is y divides x, this is exactly the way what we had written earlier, but in the language of C that we know, then we are done. We know that y is the GCD. Else we modify x and y suitably. So what would we want to set x to be? We have said x is equal to x minus y. Is there a better way to set x? In fact, we can set x is equal to x mod y. If it turns out to be 0, we are done. So if it turns out to be some other number, then in that case, we have to change, we have to repeat this process. And we already know that if x and x happens to be lesser than y, which is most likely the case when you have two arbitrary integers, and if you set x is equal to x mod y, then you are going to exchange x and y. So this is something that you can easily implement with the current set of things that we have already done. So the template of the algorithm that we are now going to, the template of the program that we are going to write now is the following. That is, we will assume x is greater than or equal to y. We'll do some pre-processing. If x happens to be less than y, we will swap it. There is a while loop where we'll have some condition that we will check. Then we modify x and y as we said. In fact, we will have x is equal to x mod y. And if x happens to be less than y, then exchange x and y. So this is something that will be most likely executed. And at the end of it, whatever is the value of y, that will happen to be the GCD of the two numbers, right? So this is a very powerful and nice idea that Euclid gave us, and due to which this is called the Euclid's algorithm for computing GCD, and we are simply writing the program for the same. Okay, so are there questions about this? Okay, there is one thing that we can also use a recursive function definition. Yes, we have not gone to functions, so at the moment I am not writing about functions and so on. Yes, it is indeed a recursive definition. Can we prove this result using strong induction? Yes, you can prove this result using strong induction, but I mean the initial part, that is GCD of xy is equal to GCD of x minus y is something that you can prove by simply doing what I had illustrated earlier, and then using that, of course, you can apply the mod operator repeatedly. Sorry, the subtraction repeatedly, which is equivalent to the mod operator. Okay, so I want you to tell me what is this condition inside the while loop. Please write down the condition inside the while loop. So in the chat messages, I request all of you to write down this condition. So this program is not written completely, right? So I would like you to write down the program and complete it for me. So all this part, right, assume x greater than or equal to y is something that I believe all of you can do. If it is not, then swap x and y. What is modify x and y as needed? It is x is equal to x mod y. What is if x is less than y, then exchange x and y. That is something that I assume that all these comments are something that you can fill up. Okay, so the conditions that some of you have given are that x not equal to y. Is that correct? I mean, do you want x to be equal to y at the end of it? So please look at this previous slide to come up with this thing. If x mod y is equal to 0, we are done. So when should we go inside the loop? This is the complete idea for the program to be written. There's nothing to be done. There's nothing not specified with respect to the program. Okay, so let's not get into breaks and write a while one condition. That is not the purpose. Write a condition which will go through, which will just fill up this whole thing. So don't change the template of the program now, while one and then do something. You just have to write down statements which are adhering to these comments. So I leave you to think about this. There are correct answers also, but the template that is given here should lead you to the answer, right? There are incorrect answers, there are correct answers, both of them are there, but x is not equal to y is something which is not correct. Okay, so as I said, modify x is equal, this modify statement that I have written here, x is equal to x minus y we can do, but there is a much powerful statement that you can use, which is x is equal to x mod y, and that is what we are going to use. So I have run out of time, but I just want some of you who are possibly having a few minutes, I'll just take a few minutes extra, and I'm going to not show the program to you, but I'm going to tell you that okay, so Kaushal, please tell whether you can see what I am sharing, which should be the rebel.it screen. Just give me a minute. Yeah, so I'm not going to show you the programs, but GCD1 is something that we have written earlier. So that is what we had completely written. GCD1 is the program for GCD. So let me just compile it as GCC GCD1.c, and actually I'll write it as -o GCD1, and then I'm going to run /GCD1 and give two inputs, right? So it is waiting for the input without prompting me, but I know that this is 10 and 2, right? So the GCD of 10 and 2 is 2, which is correctly printing it out. Now I also have a GCD, I have another program which I have called GCD2, which I'm not showing you at the moment. It has this common warning. I'll also compile it and call it GCD2. And what we are going to run is the same GCD2 with the same inputs, right? So which is 10 and 2, and it will output the same thing. So I'm not showing you the program, but it is Euclid's implementation of GCD. What I want to show you is that we have two large inputs, which are GCD inputs that I have stored, because these are large numbers that I don't want to type out again and again. So Kaushal, can you confirm that you are able to see the large inputs?
Yes, ma'am.
Yeah, and I should also tell you that these two numbers are large primes. So the GCD is going to be 1. They are chosen like that. I want to show you the behavior of these GCD1 on these two inputs. Instead of typing out these two inputs explicitly, what I am going to do is this redirect the input. This is something you don't have to worry. It is as good as saying that I would have written down these inputs, and you see that the program is taking its own time. In fact, you can time this program and you will see that it takes about a few seconds, 5 to 6 seconds to print it out. Whereas let's do GCD to the same thing, right? It's again computing GCD only, but it just does it very quickly. So this is the power of writing a very good, efficient algorithm. We'll come back to it again in tomorrow's class if there are questions, but this is what I have not filled in this. I would like you to fill in correctly, and we'll come back to this in the next class. Okay, so yeah, this was a little rushed up, I agree, but are there questions or comments here? Yeah, so I'll just summarize today's tasks that we did. They naturally required us to use loops. The finding of minimum of positive integers and Euclid's idea are natural use cases for the while construct, whereas the other things that we did, that is testing primality, the first GCD idea or the min of n integers, are actually natural use cases for the for construct, which we have not gone into right now. But we could achieve all of them using the while construct. And we have seen that break is a useful way to terminate out of the loop, and that we have used at multiple places. but a very important and orthogonal learning which is not related to the programming of the relate to the programming aspect of the course is about the power of this clever idea or the algorithm, which is this Euclid's algorithm. So with this, I'll stop the class. We'll meet in the afternoon for the lab session. As usual, it is 2:30. Today's session will be ungraded, but we will record your performance. Okay, so I'm going to stop the recording for the session.
And ma'am, about the quiz that will be happening on Monday,